In this video on astronomy concepts, we're going to look at the transit eclipse method, most often called the transit method. Let's look at three different cases. The first case we're going to look at is two stars in an edge-on orbital system called the Kepler 16 system. We're looking at a yellow star in an edge-on orbit with a red star. The red star is smaller and it is cooler because its surface is the color red, so it puts out less light compared to the yellow star by the Stefan-Boltzmann law. The yellow star is the larger star and it puts out the most light. Here we're looking at a light curve and we're looking at the total amount of brightness on the left-hand axis. So it's the vertical axis. So I'm going to write the word total in here because it is the total brightness. And then on the horizontal axis, we're looking at time, and time is increasing to the right. So we have what's called a light curve. LC for short. Now, in this first panel, we see all the light from the yellow star and all the light from the red star. So we're right about here where X marks the spot in the light curve. And this is the total amount of light. So I'm just going to put total here, T-O-T, for total. Now, when the red star is going to orbit in front of the yellow star, you're removing a lot of light from the yellow star because the yellow star is the hotter star, it's the brighter star. So we're right about here in the orbit, X marks the spot, and notice we have a very large dip in the total amount of light. Once again, we're back to our regular total light, TOT. When we see both stars, the red star had passed in front of the yellow star and it's now clear. We're right about here where X marks the spot in the light curve. And now the red star is going to go behind the yellow star. And so we're right about here in the light curve. X marks the spot. Because we're removing the red star's light, and the red star is the cooler star, so it puts out less light according to the Stefan-Boltzmann law, we have a small dip in the curve, and it's colored yellow here, compared to the big dip, which is colored blue. Once again, after the red star has come back into view, we're right about here in our total amount of light. And we see all the light from the red star and the yellow star again. And notice that this 1, 2, 3, 4, 5th panel looks very similar to the first panel. And then the last panel, we have the red star once again passing in front of the yellow star. And we're right about here in the light curve. X marks the spot. And this panel is very similar to the second panel. The last panel and second panel are very similar. So we have once again a removal of the yellow light, so we have another big dip. The larger dip compared to the smaller dip is called the primary always, and the smaller dip is always called the secondary. Now when we have a smaller star passing in front of a larger star, and you can still see the larger star in the background, it's not called an eclipse, it's called a transit. So we have this this blue big dip is called a primary transit. Then when we have the red star going completely behind the yellow star, so we don't see any of the red star anymore, it truly is an eclipse. And this small amount of light that's being removed is called the secondary. So you put the two together, we get a secondary eclipse. So we go from primary transit to secondary eclipse to primary transit, and it keeps repeating. So that's this particular case where we have a large yellow star, it's the hotter star, that is in orbit with a smaller, cooler star, and the system is edge on. We're going to look at a very similar scenario in our second case, where we're looking at an exoplanet passing in front of our yellow star. Our exoplanet is going to act like our red star in the first case. So let's take a look at this exoplanet passing in front of this yellow star. So we're looking at the exoplanet passing in front and the exoplanet passing behind. When it passes in front, it's a transit, and when it passes behind, it's an eclipse. So we know we have a transit and eclipse like we did in the first case. Let's slow this down. When the planet is just passing in front of the star, we see a major drop in the amount of light. That major drop in the amount of light is because the yellow star is putting out more light than the reflected light from the planet. So we're removing a lot of light coming from the planet, so we have a very large dip. When the planet once again passes through and then it goes behind, we are eliminating the reflected light from the planet, so we have a small dip, and that would be the secondary. And because it's completely not seen at all, the planet's gone behind the yellow star, this would become a secondary eclipse. So we see the scenario of the planet passing behind in a secondary eclipse and then passing in front in a primary transit. So it goes primary transit, secondary eclipse, back to primary transit. And most often people just call it eclipses. They'll call it a primary eclipse and a secondary eclipse. But in reality, we have a transit in this case and an eclipse. Let's go look at our third scenario. In our third scenario, we have a small white dwarf. There's your white dwarf. And we have a large cooler star. And that's your red star here. The red star is your cooler star. In this particular scenario, we have the white dwarf that is just emerging or coming out of eclipse from this red star. So we're looking at about right here in the light curve. Now, when the white dwarf is completely behind the red star, it is being eclipsed, and we have all the light being removed from the white dwarf. And it's a very big dip in the light curve because in this case, the white dwarf is the hotter star, so you're removing more of the light than the red star. In this second panel on the right, we're looking where the white dwarf is passing in front of the red star, so we're entering into the transit, and we're right about there in the light curve. And since the white star is in front of the red star and you're removing only a small amount of light from the red star, you have a small dip in the light curve. And remember, when you're at the top, it's called the total amount of light, and you're looking at both of the white dwarf and the red star in both cases. Now, because the first example where the white dwarf went behind the red star and we had an eclipse, this was your primary, your largest dip, and we have an eclipse. When we had the white dwarf in front of the red star, we had our secondary, and it was a transit. So in this particular case, we went from primary eclipse to secondary transit to primary eclipse to secondary transit, which is the opposite of the first case where we had a primary transit and a secondary eclipse. Primary transit, secondary eclipse. So in the third case, the hotter star is the smaller star, whereas in the first case, the hotter star is the bigger star. So this is 3 examples of the transit eclipse method.